Good day everyone. Today we are going to tackle about multiple linear regression. But first, let us know what is regression model. So, regression model are used to describe relationship between variables by lifting a line to the observed data. Regression allows you to estimate how dependent variable changes as independent variables change. Now let's properly start our discussion about multiple linear regression. So first, let's us define what is multiple linear regression. So multiple linear regression are used to estimate the relationship between two or more independent variables and one dependent variables. So it's stated that the tool in multiple linear regression are the two or more independent variables and the one dependent variables. It says that it is necessary that the following independent variables is correlated or are correlated to the dependent variables, but the all independent variables is not necessarily correlated to each other. So in multiple linear regression, the ideal is all the independent variables should be correlated to the dependent variable but not to each other. We can use multiple regression in a multiple way. If we want to know how strong the relationship between two or more independent variables and one dependent variables. For example, how rainfall, temperature, and amount of fertilizer added crop growth. So the following two or more independent variables here are the following: rainfall, the temperature, and the amount of the fertilizer. And otherwise, the one dependent variables is the crop growth. We can see that the following variables are strongly correlated to the one dependent variable, which is the crop growth, because the rainfall, it involves in the crop growth. It will help to the crop to grow more. Also, of course, the temperature or the weather temperature, it will involve in the crop growth. And lastly, of course, the amount of fertilizer, it will help the crop growth. So the following independent variables are correlated to the dependent variables. Next is the value of dependent variables at a certain value of the independent variables. It is somehow give a prediction or expectations to the yield of crop that they are going to have based on the levels and additions of the two or more independent variables given. It is like the outcome expected by the dependent variables are based on the value given by the independent variables. So it is really show that the independent and dependent variables are correlated to each other. Now, let's proceed to the model of the multiple linear regression. As we can see, it is stated that multiple regression is the extension of simple linear regression. The first figure, it shows the one dependent variables and one independent variables. In simple linear regression, it is one-to-one relationship. On the other hand, in multiple linear regression, it shows the two or more independent variables and one dependent variables. It is a many-to-one relationship. Like what I've said a while ago, that the all independent variables, the two or more independent variables, should be correlated to the one dependent variables. But the two or more independent variables are not necessarily correlated to each other, or they are not correlated to each other. In multiple linear regression, the y variable is the dependent variable and the x variables is the independent variable. And that is the introductory part of the multiple linear regression. And that's all my part. Thank you.
Let's proceed to the assumption of linear regression. So first, we have the homogeneity of variance. Homogeneity of variance, also known as homogeneity, it is the assumption that the variance of the dependent variables is approximately the same across all levels of independent variables. This is crucial for many statistical tests such as ANOVA and regression to ensure a valid result. If this assumption is violated, it is called heteroscedasticity, which can lead to bias standard errors and affect hypothesis meeting. Okay, pag sinabi nating homogeneity of variance, no, or tinatawag din natin tong homoscedasticity, ibig sabihin pag yung value ng dependent variable ay pare-pareho or halos magkapantay sa iba't ibang grupo ng independent variable. Ibig sabihin, ito rin ay mahalaga sa kondisyon para sa maraming statistical test tulad ng ANOVA at regression. Kapag hindi ito na i-apply or natupad, tinatawag natin tong heteroscedasticity na maaring magdulot ng maling resulta sa pagsuri. Okay, like for example example nito is first we have the homogeneous variance, so homoscedasticity. Like for example, sa mababa, yung mababa nito is 1,000 pesos minus 2,000 pesos. The variance is 1,000 pesos. Sa katamtaman naman is 3,000 minus 4,000 pesos. Yung variance niya rin is 1,000. So, sa pagmataas is 5,000 minus 6,000 is yung variance niya is 1,000. Ibig sabihin, dito sa homogeneity of variance is pari-pareho yung variance niya. Magkakaparehas yung result ng variance niya. Unlike sa heterogeneous variance o heteroscedasticity is kapag yung value ng gastos sa pagkain ay magkaiba sa bawat grupo. Ibig sabihin, dun sa mababa, merong 1,000 minus 2,500. Ibig sabihin, ay yung variance niya is 1,500. Sa katamtaman naman is 3,000 minus 500. Yung variance niya is 1,000. Sa mataas naman, 5,000 minus 10,000. Yung variance niya is 2,500. Ibig sabihin, dito sa heterogeneous variance is magkakaiba yung variance niya. Okay, paano natin tinitest? Or what was the testing for homogeneity of variance? First, we have the Leibniz test. Test if the variances across groups are significantly different. Next is the Bartlett's test. Check homogeneity of variances sensitive to normality. And last is the visual check, which is box plots or residual plots can visually indicate variance differences. Dito sa Leibniz test, dito sinusuri natin kung dito sa Leibniz test is sinusuri natin kung ang bawat variance ba is magkakapareho or bawat grupo ng variance is magkakapareho. And dito naman sa Bartlett test is dito naman is nagbibigay siya ng mas eksaktong pagsusuri, ngunit sensitive o sa normality ng data. Ibig sabihin pag nagkamali ka dito ng pag-input ng data is nasisira yung or nagugulo yung data na gagawin mo, yung normality ng data. Next is the visual check, which is gumagamit tayo dito ng box plot or residual plot upang makita kung pantay yung variance. So bakit mahalaga ang homogeneity of variance? Kapag hindi daw ito natupad is maaaring hindi tama ang resulta ng statistical test tulad ng ANOVA o regression, or magiging bias ang standard errors at magkakaapekto rin ito sa mga p-value. Okay, solution kung may mga heteroscedasticity or di kaya hindi pagkakaparehong data. First is the data transformation. Halimbawa nito, gamit ang log or square root transformation. Okay, robust test, gumagamit ng Wells, ANOVA o iba pang alternatibong test na hindi sensitibo sa heteroscedasticity. Next is tan-parametric test, gaya ng Kruskal-Wallis test na hindi nangangailangan ng homogeneity of variance. In linear regression, independence of observation refers to the assumption that the observation. Okay, next is the independence of observation. So, in linear regression, independence of observation refers to the assumption that the observation is the data set are independent of one another. This means that the value of one observation does not influence or not influenced by the value of another observation. It is a key assumption for the validity of statistical inference in regression analysis. Dito sa dependence of observation nito, ibig sabihin no, yung halaga ng isang observation ay hindi nakakaapekto o naaapektuhan ng halaga ng ibang observation. Ibig sabihin yung like for example, yung the value of the data set or the observation from one another is hindi maapektuhan yung the value of observation mo dun sa isa. Isa itong mahalagang kondisyon upang masigurado ang bisa ng resulta ng regression analysis. So, bakit mahalaga ito? Una is tamang bias-free estimates. If the observation are not independent, the regression coefficient may be biased. Second is validity of a statistical test. Tests for significance rely on assumption of independence. Violations can lead to incorrect p-values and confidence interval. 3 is error behavior. Non-independence often indicate issues like autocorrelation where errors terms are correlated violating the assumption of ordinary least squares. Example, time series data observation over time are often autocorrelated. Second is cluster data observation within groups may be similar to each other. Third is repeated measures. Multiple observations from the same individual over time are not independent.
Okay, so now let's proceed to the formula of multiple linear regression. So this is the formula of the multiple linear regression. So y is equal to beta naught plus beta 1 times 1 plus dot 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 plus beta n times n plus model error. Okay, so let's solve this problem for us to understand how to solve multiple linear regression. So we have here 4 regression variable for x2, x4, and we have here 25 observations. In a starter file called satisfaction data, starter 1, I've got a bunch of our data here and I've got some equations that we're gonna be using. In the next screencast, we're gonna use this other equation, and in this screencast, we're going to use one of these equations. And in a tab down here, I have a regression output, and it's already performed this multilinear regression model in Excel regression tool. And we compare what we get using the vector math to our coefficient here. So we're basically going to calculate beta the hat, and I'm just going to refer to this as beta, the coefficient vector that leads to the best model. In order to do this, we first need to calculate x transpose, that what x prime is. So I'm just going to go ahead and put in an x t here as just a label. Okay, so before we do that, it's really important to do a couple of things first. So I'm going to name this output data. I'm going to name that y. I'm also going to add this. It's really important if you're doing this using matrix math in Excel. We have to insert a column, and we're gonna have just a bunch of ones. Okay, so drag it down. And now what I can do is to take a column of ones combined with all our output variables, and this represent our capital X array. So I'm going to name that's capital X. Okay. So now it's ready to calculate the transpose of X. So type transpose of X and press, okay, wait, transpose and press enter. So next name, okay, wait, name, okay, wait lang. So again, press enter. So I will go up here and name this xt, that's x transpose. Now we need to calculate x t I x, x transpose times x, that's this little bit here, and I can use the mult functions in Excel, xt multiplied by x, press enter so that our xtx, and I'm going to go ahead and name this in a name box, xtx. We now need to take the inverse of xtx, so I'm going to call this xtx I and v. That's simply the inverse, matrix inverse of xtx.
Now what we gonna do is to calculate x transpose times y, the rightmost part of our beta hat calculating. So put that over here. This is xty. Let's first go ahead and name this xt, x, I, and v, xty. It's just the m mult. So we're gonna multiply xt with y, press enter, and finally, I can calculate beta. And this really is beta hat, but I'm just going to put it in as beta. Let's first name this vector xty. Beta is simply the product. So m mult of xtx inv with xty, and when I press enter, we get our coefficient. Essentially, what this means is that beta naught, that our intercept beta 1, that the coefficient here of our x1 term or age, and then we have here beta 2 is the negative 0.59, beta 3 is the 0.41, and beta 4 is a 1.31. So let's compare these values. So I'm just going to go ahead and just copy. Let's go over to our regression sheet and just paste them over here. We're here. So on the right, and you see that they align nicely. So this is how Excel regression tool is calculating the coefficient for a multiple linear regression. And that's all in my part. Thank you.
Let's proceed to the things that can calculate via multiple regression. But first, let's define the multiple regression based on the previous reporter. So, multiple regression is a powerful statistical technique used to analyze the relationship between a dependent variable and two or more independent variables. It says that the multiple regression is an extension of linear regressions which only consider one independent variable. Just like what I mentioned, multiple regression can compute three things. So the first is the regression coefficient that lead to the smallest overall model error. So multiple regression does not calculate any coefficient. It also calculates the estimated regression coefficient. This is the core principle of the ordinary least square or OLS estimation. The SSR represent the overall model error, the difference between the observed dependent variable values and the values predicted by the model. Minimizing SSR leads to the best fitting or lines or hyperline in a multiple dimensions. And that is the second one. And the last one is the associated p-value. How likely it is the statistic would have occurred by chance if the null hypothesis of no relationship between the independent and the dependent variable was true. So let's explain the number 3. So the p-value associated with its t statistic or the f statistic for the overall model indicates the probability of observing the obtained result or more extreme result. If the null hypothesis were true, a small p-value, typically below a significance level such as 0.05, suggests evidence against the null hypothesis. It is crucial to remember that a p-value does not indicate the probability that the null hypothesis is. That's the three things that the multiple regression can calculate or compute. So always remember that the multiple regression is a power tool for understanding complex relationships between variables. However, it's important to understand its assumptions, limitations, and potential pitfalls to ensure that the results are reliable.